Okay, we are going to talk about bit field representations. All right, we have declared a structure with the three member variables. Each of them is unsigned int, so it's 4 bytes, 4 bytes, and 4 bytes total of 12 bytes. Okay, and in the past we always declared either char or unsigned char, which is 1 byte, a short 2 bytes, and int say 4 bytes, right? And of course by double, we did a lot of that, double, float, all that. But if you want to represent or define variables that requires the number of bits to be anywhere from let's say it's not a multiple of 8 bits. Let's say a variable requires only 11 bits, another variable requires say only 4 bits, or let's keep it let's say 7 bits and 6 bits, like that. We use a bit field representation using structure. The way we do that is, let's pretend here I'll erase this here so I'll have more space. Let's pretend here the x requires 11 bits, okay, and y requires 7 bits, z requires only 6 bits, okay, number of bits needed. All right, and so what is the total number of bits here? 11 plus 7 is 20, is 18. 18 plus 6 is 24 bits, so 24 bits. So the way we represent that, all right, using the structure, is to change. Let's take a dark blue here. Is unsigned int x semicolon 11, and you put a semicolon there. So here we are saying x is a member of data, all right, and whose size is not 1 byte, not 2 byte, not 4 bytes, but it is 11 bit. That's what the representation is. Let's take for y 7 bit. See that? And z is 6 bits. So by doing that, okay, we are now saying z can only hold a value between 0 to 63, right? 6 bits means 2 power 6 minus 1 is 63, and 7 is 0 to 127, and 11 is 0 to 2047. Yeah, data range. Previously we were not able to do that. We are not able to define variables in like this, right? We are only able to define variables in multiples of 8 bits, but here I can define variables in using the number of bits representation. Okay, so now what happens is, let's go and figure this out. Okay, let's write this program and see the size of data, and that's one thing we'll see. The second thing is how to access member variables. All right, So this is the program I wrote, much similar to what we have been talking. All right, x, let me check if I can show it here like this. Yeah, good. X is 11 bits, y is 7 bits, z is 6 bits. All right, and I put some values here. X702 and y is 50. This is all hexadecimal, and z is 30, hexadecimal 30. All right, and we'll print the size of data. What is the size of it? And we'll take simple example of printing. We're done assignment here. This is the assignment statement, and here we are access the member data. Okay, very simple. So let's go ahead, compile it. Just no problem. If you see here, I was able to data x as the value. Let me print the value of y also. So we have to make sure that we're not overwriting anything. Uh, it got into a mode where it stopped doing stuff. Okay, let's print the values. Let's compile it, clear it, and we're able to assign and read values from the data members. But if you see here, the size of data is 4 bytes, but we've only required 24 bits, which is 3 bytes. Why is that? Here it's printed 4 bytes. The reason is okay, good job. The reason is, I'm going to erase this for now. Remember, we can only allocate, oh, I'm sorry, either 1 byte, 2 bytes, or 4 bytes. There is no data type for us to allocate 3 bytes. This is char, this is short, and this is int. Because this requires 24, the compiler and unsigned int is 4 bytes, so it allocates extra memory called int. We don't know the name. It allocates extra 8 bits here automatically for you. You can either use it or don't use it. You can say undefined maybe. So that is why it created the extra 8 bits to make it 4 byte. Okay, so if you go back to the definition, so it basically creates a unsigned int undef 8 bits. See that? And so this is how you create variables with various with bits sizes. All right, the standard actually allows only unsigned int signed int, okay, but some compilers but some compilers allow unsigned chars. It depends upon the compiler, but unsigned int and signed int is the most portable. Okay, so for instance, if you go back here, I will copy this guy, copy 1.c to 2.c, 2.c. If you take it, if I convert that into char, that is char, that is char, that is char, but char is unsigned char is 8 bits, right? Unsigned char is 8 bits. So we need to represent x and y within, let's say that's 1 bit, y is 2 bits, z is 3 bits, and undefined is say 2 bits. So how much is it? 1 plus 2, 3 plus 3, 6 plus 2, 8. So that's good. So we need to now change x 1, 1 because it can only have one value, right? X 1 bit, that means 0 or 1. Y is 2 bits, that means it can take a value between 0 to 3, and Z is can take a value says, yeah. Now if you look at the size of data using this example, it is 1, yeah, and we're able to read the values we assigned. So but this is not portable code, not portable code, okay, whereas the other one is portable. Why is that? Because this portable code, because this is what the standard says,